All right. So, uh, oftentimes, whether something is overgrazed is really obvious, right? So, if we look at these four pictures, it becomes very clear based off how much standing forage there is in these pastures, which of these is being overgrazed. Okay. So, based off that, this panel D, it's very clear, has the highest grazing pressure and is likely being overgrazed. Compared, panel C is probably the next highest grazing pressure. Panel B is probably the second lowest grazing pressure. And then panel A probably has the least amount of growing pressure or grazing pressure. Okay. So same concept here, right? So we have panel A, B, and C. Which of these pastures is being overgrazed is quite obvious, right? Pasture C, you can see very low, uh, uh, very little amount of forage mass here in this pasture. Okay, panel B is probably intermediate. And then panel A has the lowest grazing pressure and the highest amount of standing forage mass. Okay, so just keep in mind that it's not yes or no if uh, uh, a pasture is being overgrazed or not. It's really kind of a spectrum, right? Okay, so in general, stalking methods, all right. So if we turn cattle out onto a pasture and they have full access to the whole area for the whole length of time that they're grazing, we would call that continuous grazing. Okay. So continuous grazing, by definition, is a method of grazing livestock on a specific unit of land where animals have unrestricted and uninterrupted access throughout the time when grazing is allowed. Okay. So over that whole grazing period, um, they have access to the full pasture, their full unit of grazing land during that whole grazing period. Okay. So rotational grazing, on the other hand, is where we take that whole pasture area that's being allocated to those animals and we subdivide it and we only allow them to have access to a given amount of land. And then after a period of time, the grazing interval, we rotate them to the next pastures. Okay. So that's rotational grazing. Um, Important thing about rotational grazing is when the animals are not in that subdivided paddock, the forage is allowed to rest, and we're not giving the cattle an opportunity to regraze already grazed plant species. Okay, so by doing that, you can help that perennial plants longevity. They're not going to be uh, depleting their root stores, energy stores in their roots near as often, and so it could be beneficial to the plant. Okay. Also by rotational grazing. Somebody say something. Did somebody say anything? Or are we good? Okay. All right. Just interrupt if you have any questions or you need me to slow down or re-say something again or try to re-explain it. Okay. Um, but another key distinction with rotational grazing is by subdividing that paddock, we are increasing stalking density. We're not changing stalking rate, but we're increasing stalking density. And so whenever you increase stalking density, you have more competition. So the animals are going to have lower selectivity. And so what that's going to do is it's going to increase forage utilization. So how much of that above ground forage mass is actually being consumed by that animal? Okay. Um, so forage utilization is the percent of above ground forage mass that is being harvested by the animal. So if we can increase that forage utilization to a large enough degree, then they are utilizing more of that above ground forage mass. You may be able to actually increase stalking rates, okay, compared to a continuous grazing system. All right. So all types of grazing management are really manipulating stalking density. Where they differ is how long they're held within that subdivided paddock, and then how long until they return to a paddock that they've already grazed. Okay. So where the management aspect comes in is around these four aspects of grazing management, right? So there's frequency. So how often are these paddocks being grazed in a growing period? So you can see that here in this top panel. Um, a high frequency means uh, that a specific paddock, gets grazed more often during a grazing period. Okay, so it could be uh, how frequently they're being rotated between the different subdivided paddocks. Okay, compared to this low one, um, uh, there's a longer amount of time before they arrive back to a paddock or a subdivided paddock that has already been grazed. Okay, there's timing. So when in the growth period are you going to target cattle to be turned out? And this is growth period of the forage. When in that growth period are you going to target cattle to be turned out um, to actually graze the plant species? Okay, so you can do that early when the forage mass is low and it's more vegetative, technically would have higher quality, but there's going to be less of it. Okay, or you could time it to where you turn cattle out to graze these forages late when their forage quality is less, but forage abundance is higher. Okay. Then you have duration. So a short duration uh, duration is the residence time of cattle in the pastures. So how frequently are they rotated? So a short duration rotational grazing system could be we're allocating a new area to these cattle every day, right? Compared to a long duration, maybe we rotate these cattle once a month. Okay. So based off of pasture duration, residence time, that's going to tell you how big of the subdivided paddock areas you need to be allocating to these cattle, because you need to make sure that uh, they have adequate forage mass in those subdivided pastures to support them throughout the whole residence time. Okay. And then finally, you have intensity. So what is your target forage utilization? Okay. So a low intensity would be your target residual forage in the pasture. So by residual forage, I mean amount of forage that is remaining after you stop grazing, after you move them to the next subdivided paddock. So a low utilization could be we turn cattle out, we only allow them to consume 30% of the available forage, and then we rotate them to the next pasture. Compared to a high forage utilization, you turn a group of cattle out and you don't rotate them until they've consumed 90% of the dry matter that's in that paddock. Okay. Obviously, a lower utilization, a lower grazing intensity would have less impact on those available root stores for the plants, would have less disruption on forage regrowth, and would have uh, longer increased longevity of that forage species compared to a high intensity. However, a high intensity is this producer is going to get more out of their above ground forage mass, um, and uh, can more so capture. So typically, can more so capture the available resources to them. Okay, so typically annuals will target a lower residual dry matter because we don't really care if they grow back because they're not going to grow back, right? Whereas perennials will target a less intense and we want a higher residual dry matter after we turn or move cattle to the next area, um, because we do want them to support their root system and to have that longevity. Any questions about this? So on exam 2, if I give you the definition of these terms and ask you to match them, would you be able to do that? Okay, so that could be an example of a question I could give you for exam 2. Okay, so why increase stalking density? So there is a few reasons why we'd want to do this. As I've mentioned before, all types of grazing management strategies rely on changes in stalking density. So the difference between different management systems becomes in the when do we want to turn cattle out, where do we want to turn cattle out, and how they are allocated or to a specific area. So what size of an area are we giving these animals? Okay. So one reason why we want to increase stocking density is to allow for rest and recovery. Okay. So rest is where no grazing happens for a prolonged period of time. It allows plants to reach maturity, and uh, so it's a longer time without them being grazed. Okay. So this, as we mentioned before, this can improve the longevity of perennial pasture species, can reduce overgrazing of preferred species so that they're more fully utilizing the forage resource that we're allocating to these animals. Um, if we do not have a high enough stocking density where cattle can be really selective of while they're grazing, sure, that animal's going to have a higher quality diet. However, they're going to overgraze preferred species, which could result in an accumulation of unwanted species in that sward. Okay. So compare that to recovery. So after a grazing event, we allow plants to restore or repair energy stores and then regrow new leaves prior to grazing again. So um, a lot of rotational grazing systems are uh, trying to allow recovery and not necessarily rest. Okay. So most grazing management, most rotational grazing systems are targeting a recovery, and they're trying to keep that plant in that phase 2 of growth. Okay. They want to target that grazing to occur when it's still in the vegetative stage, so that it's balancing rate of forage accumulation and forage quality. Okay. Some of the more regenerative practices are grazing practices where they have uh, like short intensity but frequent rotation grazing events. They're trying to more target that rest as opposed to recovery. Okay. All right. So another reason why we want to increase stocking density, like we've said, is to increase harvesting efficiency. Okay. So this is the percent of forage mass that is actually consumed. And you guys need to know what that is. Okay. You will use it in calculations that we'll go over in just a second. So if harvest efficiency is improved to a great enough degree, okay, we're making these animals utilize more fully the forage resource that we're giving them. Okay, so there's more available forage that can actually be consumed by the animals or will actually be consumed by the animals. We can increase stocking rates. Okay, so maybe you can run more cattle per unit area, increased harvesting efficiency, and if you're running more cattle, you can make more money. Okay, so we have three different tables here. This first one shows kind of the optimum grazing period. So this would be how long do we want these groups of animals to be within a given paddock before we rotate them to the next paddock. Okay, so here we have three different animal types. So we have cow, calf, sheep, or goats. Then we have stockers or younger growing beef cattle, and then we have dairy. Um, so an optimum grazing period for cow, calf, sheep, goats would be somewhere around 3 to 7 days. So that would mean you're rotating cattle to a new paddock every 3 to 7 days. So twice a week or once a week. Okay. Stocker yowing cattle, the optimum grazing period is shorter. So somewhere around 1 to 3 days. For dairy cattle, we want really high frequency where you're allocating and you're strip grazing these dairy cows if you have a forage-based dairy system, which is not common in the U.S. There's some in Missouri. I'm sure some others in the U.S., but this would be the type of grazing periods that we would implement for grazing dairy cattle in New Zealand. We would be allocating a new strip of grass every day. Okay. Here we have recommended rest periods for an introduced species. So this would be like a Bermuda grass compared to a native species. Um, so these would be like your tall grass prairie species, short grass prairie species. Okay. So here's growth rates. So if we're wanting to uh, 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 target a rapid growth rate for introduced species, we need to not have them graze that area again for 15 to 25 days. For natives, they take a little bit longer, so 25 to 45 days. If we're targeting a moderate growth, or if we have achieved a moderate growth for introduced species, we're going to need 25 to 35 days. For natives, we'll need 45 to 60. And then for slow growth periods, we would need to target a 35 to 50 day rest period compared to natives, which again require a longer period of time. So you don't need to necessarily remember these concepts or these exact figures. You just understand the concepts. So depending on the growth rate that the plants are in, that will require a shorter rest period. Okay. And then introduced species need shorter rest periods than natives. Okay. So this shows you different grazing systems here. So continuous grazing. If you implement a 4 to 6 pasture rotation system, an 8 to 10 pasture, 12 pasture, or if you're strip grazing where you're allocating a new strip of grass daily. Okay. And here this tells you what kind of pasture utilization or harvesting efficiency you can expect to achieve with these different grazing managements. So as you increase the number of pastures, you are going to shorten the residence time that animals are in that given pasture. So you're going to have more frequent rotations. Okay. And these would also have, as you go from 4 to 8 to 12, these are also going to have higher stocking densities because you're subdividing your total area into more subpastures. Okay. So for native species in a continuous grazing system, we can expect a 25% harvesting efficiency. For introduced species, we can expect a 30%. Okay. If we increase the number of pastures to 4 and we start implementing rotational grazing, we're not going to necessarily see an improvement in forage utilization for natives. However, we will see an increase in forage utilization for tame or introduced. So that'd be like a Bermuda grass. Okay. If we go up to 12 pastures, that's where we see a big jump in the forage utilization, pasture utilization of, of native versus for both natives and introduced species. So if we have 12 pastures, so increased stocking density, we can expect a 35% forage utilization for natives or a 60% for introduced species. Okay. If you are strip grazing and you are allocating a fresh break of grass to cattle at a very frequent interval, you can expect, and so you have really high stocking densities, you can expect as much as 75% forage utilization for introduced species. Okay. So now we're going to start getting to some of the calculations that you guys are going to need to know for exam 2. Okay. So one, what is an animal unit equivalent? Okay. So one animal unit is 1,000 pound cow. Okay. With calf. Okay. So you can see that here in this table. So here we have beef cows, body weight is 1,000. That animal unit per head is 1. Okay. So if we know what the body weight of a class of animal is, we can multiply it by 0.001, or we can divide that body weight by 1,000, and that'll tell us what animal unit equivalence that class of animal is. Okay. So for example, if we have a 1,300 pound cow, 1,300 times 0.01 is 1.3. So that 1.3 or that 1,300 pound cow is 1.3 animal units equivalents. Okay. Another example, if we have a 750 pound steer, stocker animal, heifer, whatever, that 750 times 0.001 is 0.75. So that 750 pound stocker is 0.75 animal unit equivalents. Okay. Just as an example, BLM is charging producers to graze federal lands for $1.35 per animal unit month. Okay. So if we had 1,000 beef cows and they were 1.3 animal units equivalents, you could multiply that by 780 because there's 700 in a month in a 30-day period. One animal unit is going to consume 780 pounds of forage, and that'll tell you how many animal unit months you have. Okay, you multiply that by $1.35, and that's what BLM would be charging you to lease their land. Any questions so far? Okay. All right. So here's some example calculations. All right, in this example, we have 100 stalkers. They're weighing 600 pounds, okay, body weight. We plan to graze them for 5 months. So 5 times 30 is 150 days. If we have 300 acres, how many animal unit how many animal units do we have? How many animal unit months and animal unit days? Okay. So for example, 300 acres. So we can calculate our stalking rate. Okay. So if we have 300 acres divided by 100, because we have 100 animals, times zero point 0.6, because this 600-pound steer is 0 0.6 animal units, and then times 5 months, we have 1 acre per animal unit month. So this is an example of stalking rate, right? So it has the area, has an aspect of animals, number of animals, so animal units, and then an aspect of time, so month. Okay. Another example of this, so we have 100 stalkers. They're 0.6 animal unit equivalents times 150 days, and then divide that by 300 acres. So here we have 30 animal unit days per acre. Okay. We can also calculate the total animal units. So I misspelled animal here. So we have 100 times 600, because they're 600 pounds, times 0.001. So we have 60 animal units. Okay. So we can take that 60 animal units, we can multiply it by the number of months, and we have 300 animal unit months. Okay. We can also calculate the total number of animal unit days. So we have 60 animal units times 150, so that we have 9,000 animal unit days. Okay. Any questions on this? Does this all make sense? Okay. Okay. So, oops. All right. Here we have a suggested residue height for selected introduced forages to optimize animal performance and stand persistence. Okay. So, one second. Oh, no quiz today. Okay. So here we have our forage species. We'd want to, for example, for alfalfa, we would want to target a 4 to 6 inch residue. And this is the maximum utilization or harvesting efficiency that we want to achieve for alfalfa. So 50%. So that means we'd only want to defoliate that plant by 50%. Okay. Here's let's look. Here's annual ryegrass. We'd want to target a 3 to 4 inch residue height after we stop grazing. And the maximum utilization or maximum forage or harvesting efficiency we'd want to achieve is 75%. Compared to white clover, we'd want to target a 2 to 3 inch. And again, we wouldn't want to go over a 75% harvesting efficiency. Okay. So we know that 300 animal unit months, which we calculated here in this example, okay, we know that one animal unit month is going to consume 780 pounds of forage. So in this example, we have 300 animal unit months times 780. We would need 234,000 pounds of grazable forage to support our hypothetical scenario uh, uh, for the 5 month period. Okay. We can do the same thing for animal unit days. So we have 9,000 animal unit days, which we calculated here. Okay. Times 26, because one animal unit day is going to consume 26 pounds of forage. So we get the same number, right? So 234,000 pounds of grazable forage needed. Okay. So if we have 234,000 pounds of forage needed, we can divide that by the number of acres. And so we would need 780 pounds of grazable forage per acre to support these animals. So um, let's assume cattle are grazing old world blue stem. So we can come over here. 65% is maximum. but we're going to just assume we're going to graze half and leave half. Okay. So we're going to assume 50% of that old world blue stem is going to be ungrazed. Okay. We're going to lose 25% due to trampling. And so 25% of that forage is going to be consumed. Okay. So, so that is a harvesting efficiency of 25%. Now, the other key distinction here is we have a 50% defoliation rate. Okay. But of that 50% defoliation rate, only 25 is being consumed. Okay. So we have 780 pounds of grazable forage per acre needed. Okay. Divide that by 0.25. We would need 3,120 pounds of forage dry matter per acre to support a 100 stalkers at 600 pounds for 5 months. Does that make sense? Okay. Please interrupt if you have any questions. Okay. So here's another example. Okay. We have 6,000 pounds of forage per acre and we have 200 acres. So how many animal unit days can we graze if we're assuming 50% is available for use and we're going to leave ungrazed 50%? Okay. Oh, and 50% of that, so we're going to have a 25% harvesting efficiency. Okay. So 6,000 pounds times 200 acres. So we have 1.2 million pounds of forage here in this area. Okay. 1.2 million times 0.5 times 0.5. So there are 300,000 pounds of grazable forage. Okay. So we're calculating how many animal unit days can this area support. Okay. So 300,000 divided by 26, because one animal unit, it will consume 26 pounds of forage per day. Okay, so that tells us we can support 11,538.4 animal unit days. Okay, so that ends up being around 57.7 animal unit days per acre. Okay, so how many animal units over a 75-day grazing period? Okay, 11,538.4 divided by 75. So we can support 153 animal units over that 75-day grazing period. Okay. So if we're grazing 600-pound steers, that 153.8 animal units divided by 0.6 will tell us 256 steers can be grazed on this 200 acres that has 6,000 pounds of forage per acre for that 200 for that 75-day period. So 256 divided by 200, this is running 1.28 steers per acre. Okay. Everybody is following all this? Okay. So we can do the same example, but here we can, instead of using instead of using animal units, we can just go directly from amount of forage to number of steers, and the math will work out the same. So again, we have 300,000 pounds of grazable forage. So 600-pound animal will consume, if we're assuming 2.6% of their body weight per day. So a 600-pound animal can consume 15.6 pounds of forage dry matter intake per head per day. So how many days are they going to be grazing times 15.6? So one steer is going to consume just under 1,200 pounds of forage over that 75-day period. Okay, so 300,000 pounds of grazable forage divided by 1170. Again, we get that 256 steers can be supported in this example. So we get the same numbers. Okay. Here is an example of what you could be tested on. The tables will look kind of just like this. Some of these unknowns may be different. Some of the unknowns I may swap with some of these knowns, but in your test, exam two, you'll be given a table just like this, and you'll have to answer some of these uh, unknown left blank cells. Okay. So here we're going to compare a continuous grazing system to a rotation grazing. The rotation grazing, the only real difference is because we're increasing stocking density, we're going to have a higher use efficiency or forage or harvesting efficiency. Okay. We're going to go take it from 25 to 35. Okay. Otherwise, everything else is the same. So here's that table filled out. Okay. So to calculate forage available to graze in pounds per acre, we take that 6,360 times 0.25 for the continuous, and then times 0.35 for the rotational grazing. Okay. Then forage that's available to graze, we multiply these two cells by uh, uh, 640. So that tells times how many acres we have. Okay, so for the continuous, we have 1 million, just over 1 million. For the rotational, we have 1.4. Okay, so how much total dry matter intake would a 750-pound steer need? Um, so 750 times 0.026 times 150. So each over that 150 days, they're going to consume just shy of 3,000 pounds of forage. So how many stalkers can we have? Because of this lower harvesting efficiency, we can only have 347 for the continuous system compared to 487 for the rotational system. Okay. So what is our stocking rate? Um, if we go acres per steer, so we got 640 acres divided by 347 steers. So our stocking rate is 1.8 acres per steer for the continuous system, and it's 1.3 for the rotational. So we're able to increase stocking rate by implementing this rotationally grazing, and we only increased our harvesting efficiency by 10 percentage units. Okay. So our overall forage allowance, pounds of forage dry matter per pound of body weight, is 14.5 for the continuous compared to 11.1 for the rotational. Okay. So this just making the point here that why would we want to increase stocking rate? Well, if we can increase our harvesting efficiency by increased stocking density, and therefore we can potentially increase our stocking rate, you would have you can run more steers and maybe be able to be more profitable, generate more income per acre. Okay, so here's some examples of just running through some simple math with stocking density. If we have 8 paddocks, okay, what is our grazing period? So the number of days within the paddock. Uh, so number of days within the paddock, so our grazing period. So 640 acres divided by 8. So each paddock in this example is 80 acres. 80 acres has 2,200 pounds of forage mass available just in this example. So each uh, each paddock has 178,000 pounds of forage available to graze per paddock. Okay, so that 178,000 divided by 19 and a half pounds of dry matter intake per day times the number of head, we can graze that 80-acre subdivided paddock for 18 days before we need to rotate it to the next paddock. So what is our stocking cycle? So that's the length of time to do one full rotation through all the paddocks. So if we have 18 days times the number of paddocks, which is 8, so that's 144 days. So how many days of rest per paddock? That stocking cycle minus 18, because they will be within that original paddock for 18 days, equals 126. So we are allowing those that area to be grazed or to be grazed relatively high intensity over an 18-day period. Okay. But then we're allowing it to have rest and regrowth for 126 days. Okay. And importantly, in a stalker situation, um, with that 126 days of rest, you're probably only going to graze that subdivided paddock once in a whole grazing period. Okay. So the the perceived benefit of stalking or rotational stalking, rotational grazing is, maybe these more closely mimic native systems. And whenever I say native systems, I'm talking about the large herds of migratory bison that used to graze within the prairie, right? They would go to an area, have huge stock densities, uh, graze the mess out of it, and then leave it. And then that area that they had just grazed will oftentimes have at least a year, maybe even longer, of regrowth to recover from that grazing activity. Okay, so here's an example with 12 paddocks. We have 640 acres divided by 12, so these paddocks would be 53.3 acres per paddock. So 53.3 times, we had 2,200 pounds of forage mass available to graze per acre. So each paddock has 118,000 pounds of forage available to graze. So 118.645, the amount of forage available to graze divided by 19 and a half pounds per day times 487 a head. We would need to rotate from each paddock every 12 days. Okay. So in this instance, our stocking cycle is 12 days times 12 paddocks is 144 days. How many days of rest per paddock do you get here? So 144 minus 12 is 132. Okay. Compared that to here was only 126. Um, but again, most paddocks would only be grazed one time, right? And this just shows an example of what the thought is that bison would have had. So the bison stocking density was estimated to be about 0.15 acres per head, right? So they were bunched in there real tight in that given area, okay? And they were estimated to only have grazed 13% of a given area at a time, okay? Before they would move on to a new area and allow that area to rest and recover over very long periods, right? So just the point trying to make here is that yes, rotational grazing more closely mimics what, especially for these native species, but what they were co-evolved with the grazing bison herds. Okay, um, do it on time. I think we're going to have about 35-ish minutes uh, uh, to have a test review if there's any questions. So if we provide and give an area an adequate amount of rest, can we regraze a pasture? So if we assume that forage mass growth rate is 10 pounds per acre per day, then 132 days of rest would yield an additional 1,320 pounds of forage per acre. So this is about 59% of the forage that was originally available to graze, right? So by accounting for forage growth during rest, could we further defoliate these plants? Would be the question, right? Could we increase stalking rate, reduce the grazing period, and have another round of grazing? Because during that rest period, we allow these plants to accumulate more forage mass. And ultimately, this kind of depends on the forage growth rate, which is going to depend on rainfall, which is also going to depend on season, right? Um, so this one paper by Broomer determined that tallgrass prairie grew at about 54 pounds per acre per day in May, but it only grew by about 4.5 pounds per acre per day in late August, early September. Okay. So, like around 10 times less in late summer growth rate than it did in early summer. And importantly, this growth rate did not matter if it was being grazed at the time or not. Okay. Now let's compare this to a winter annual species. Okay. Wheat pasture has a rule of thumb that it'll grow 3.5 pounds per acre per growing degree day. Okay. So a growing degree day is the average daily temperature during that time minus the critical temperature. Okay. So the critical temperature for wheat is 32 degrees Fahrenheit. So in essence, wheat will grow as long as the temperature is above freezing. Okay. When it gets below freezing, it won't grow during that time. Okay. So Another example here, we have improved forages like Bermuda grass. It's been shown to have been able to grow at 150 pounds per acre per day. Okay. Bahia grass can be anywhere from 35 to 120 pounds per acre per day. And this is all going to depend on season. And then short grass prairie, I don't have it here, but it's going to be close to this tall grass prairie. Early May, it's going to have a much higher growth rate than late summer. And all of this is going to be driven by climatic factors, right? Okay. Here, looking into forage growth rates, let me see how many slides I have left. Oh, this is the last one. Okay. So the amount of forage accumulation that can occur is going to be driven by um, the forage species, okay, season. So you'll have faster rates of growth during the peak growing season. So weather and climate, rainfall, largely rainfall and temperature, and then fertilization rate. So um, and for fertilization rate, I'm really only talking about introduced species like Bermuda grass, Bahia grass, and I'm not talking about native species. Um, improved or introduced species will respond much better to nitrogen fertilization than native species. Okay. So here we've got just kind of a summary graph I took out of Monty Roquette's book that shows the growing season for different forage species. Here in this yellow or warm season grasses, here in the green are cool season grasses. Um, and then this orange is cool season grasses and some warm season grasses, but that are actively being available to graze in the fall. And then here in the blue is some forages that would be available to graze in the winter. Okay, so you can see Bermuda grass, Bahia grass, you can really start grazing from May to early-ish October compared to these fescues, which would have a kind of a bimodal growing curve where they'll grow kind of in that early spring um, through late or early summer, and then it will have another peak of growth that's occurring in that fall period. Okay, so here in this figure down here, we have forage mass, and then we have date of the year, and this is for Bermuda grass. So this is kind of a common growth rate that you would expect to see for Bermuda grass from March to November. So early or mid-March, you're not expecting much forage mass to be grown by Bermuda grass. However, as it goes into the summer, especially early summer, it's going to have its highest growth rate. Then it's going to start to kind of tail off as you go into late summer and early fall. Now, here, this is small grain, annual pastures, and annual ryegrass. So in fall, you'll see a little peak in growth rate. And then in that spring, what they call the spring flush, you'll see most of that forage mass accumulation occurring. Okay, so we have finished lecture 7, and now we're going to switch gears. I'm going to stop sharing my screen, and I'm going to turn it over to you guys and let you guys ask me any questions related to exam 1.
Could you just real quickly go over all the BRD viruses and then what info we need to know about BRD? Thank you.
Can you unmute?
Am I muted? How long have I been muted?
The
Can you
whole
guys hear
time you
me?
were talking about the BRD. I thought you were just highlighting them.
Oh, yeah, I was talking. I was on mute. Sorry, guys. All right. So I guess I've been muted for a long time. So I'm just going to start again. All right. Uh, the BRD comp. So know that poor prior management, mainly around weaning and vaccination status before they enter to the auction markets, is going to increase morbidity and mortality, largely driven by bovine respiratory disease. Okay. So BRD is the number one uh, uh, disease cost to the beef industry. Okay. So you guys are going to have to be able to spell out uh, these viral agents. Okay. So these are the initial uh, infection. So the animal initially gets infected with these viral agents. Okay. These agents suppress immunity and allow these secondary infections by bacteria to infect the lungs, right? And that's where you get these lung abscesses. All right. So you're going to need to know how you're going to have to provide these five viral agents. So if, for undergrads, I'm going to give you the abbreviation. Okay. Um, and then you're going to, so if I give you IBR, you're going to spell out infectious bovine rhinotracheitis. Okay. To the best of your ability. Does not have to be perfect. Okay. Then another example, if I give you BVDV1, you're going to spell out bovine viral diarrhea virus 1. Right. Um, and then you're also going to have to provide these three uh, bacterial agents of BRD: Staphylococcus somni, Mannheimia hemolytica, and Pasteurella multicolta. Okay, does that make sense? That is 1000% on the exam. Any other questions?
You said you were going to give us the equations for all the math questions, correct?
Yes. Yep. So I uploaded those
Okay.
example problems. Those were literally from exam one last year. You will
Okay.
have very, very, very similar ones this next year. The numbers will be different, but everything else will be the same, right? And I'm going to give you that exam or that equation sheet that is also in those examples. Okay, so make sure you work through that so that when you come to exam on Tuesday, it's not the first time you're seeing these outside of our lecture, right? So that'll be a good study practice. Undergrads, you're going to be doing this Monday in lab.
For the graduate students, how many regular questions are there and how many math questions are there?
There are 10 multiple choice, somewhere around, I'm going to say somewhere around 20 short answer. And then there are, well, the math questions are the ones I posted on the review. So for the exam, if it takes you longer than you have available in class, I'm not going to make you turn in an incomplete test. If you need more time and you have available time right after the class period, you can come with me. We'll find a spot to set you up and let you finish. Um, or if you need to schedule time to come back and finish it up, we can do that too. Um, Main thing is I don't want time to be an issue. However, most people should be able to finish the exam in the given time, especially graduate students. And that's part of the reason why I'm having the undergrads do the math part and lab so that they're not being real pressed by time.
Are we going to need to interpret any graphs? Because I know you've had a lot of graphs in the slides. Do we need to be prepared to like have that on the exam?
No, not this first exam. The second exam, you will have to replicate some of those, but I'm trying to make sure I tell you exactly which ones of those you need to know, right? Um, but this first one, there's not a question like that.
Okay, thank you.
Yep, you bet. Um, Now there's going to be some questions from that first lab too. Okay, so graduate students make sure, and graduate students, you should know all the concepts we talked about in that first lab, the kind of feeds and feeding nutrition review. Okay, but all that information is free game. So if I ask you a question of why do heifers at the same body weight, at the same rate of gain, require more net energy for gain than steers? Okay, be able to answer that. Does anybody know why? Why would heifers at the same body weight and the same rate of gain require more NEG, mega cows of NEG, than steers?
Is it because they reach maturity quicker?
Yep. So at that stage, they're at a higher stage of physiological maturity. So they have more fat uh, deposited within that average daily gain. That average daily gain will be more composed of fat than for steers, and it takes more energy to deposit a pound of fat than it does a pound of lean tissue.
Just to make sure I'm right, the first exam is everything from the first lecture up to the best management of weaning and consequences of poor management
Yeah,
PowerPoint.
that one. This one I have open right now. The uh, best management of weaning. Yeah, that one's going to be the last one that's you're going to be tested on. Okay, guys, I will hang around as long as you guys want. You're welcome to leave whenever you like. But get to asking some questions, I reckon.
I'm looking at the equations for exam one that you had posted on Canvas, and number one, number six, and number seven are blank. Did graduate students need to already know those equations?
All right, say that one more time, please.
I'm looking at the equations that you posted on Canvas for exam one,
Yep.
and number one, number six, and number seven are blank.
1, 6, and 7.
Are those equations that graduate students need to already know?
All right, let me pull that up. So yours does not look like this?
Let me try to refresh it because no, it does not. No, sir, it doesn't, even after I refreshed it.
Is anybody else having any issues with what was uploaded into Canvas? Let me see.
Yeah, I don't see him either.
So yours does not look like this?
No, sir.
Okay, I don't understand how that could be possible, to be honest. Um,
Let me try it on my laptop and see if that makes it better.
and you're in the graduate one?
Yes, sir.
Maybe try to download it. How do you download it?
I just downloaded and it looks as it should.
Okay. Yeah,
If
this
you're
looks a
on,
little funky here, but
if you're on
uh,
the Canvas app, it kind of like messes it up, but if you go on like the web browser for Canvas, it looks normal.
okay.
Perfect.
Yep, I've never used the Canvas app. I didn't even know there was one, to be honest.
Yeah, it messed up mine, but then I opened it on the browser and it looks like yours.
Okay, cool. If you want, just maybe send me an email and I can email it to you too if you don't want to deal with that on Canvas.
Okay, perfect. Thank you.
You betcha.
I have the same question as someone in the chat. For like the overview of the beef industry, there's a whole bunch of different, I guess, maps of the United States of like, oh, this is where this is and this is where this is. How many of those do we actually need to know, or like what's important from that lecture? Because it's a little overwhelming looking at, 20 different regions at once.
Okay. Um, the main thing that you guys need to know from this lecture, okay, is feeder supply, what it represents. Okay. So what does feeder supply represent?
Is it like the amount of cattle that aren't on feed, like in a feed lot?
Yep.
Open.
Yep, exactly right. So in essence, they provide an indication of cattle that are stocker cattle, right? But yeah, literally they are feeder cattle that are available to enter the feedlot. Okay. And so stocker ratio, okay. So that's feeder supplied as a percent of calf crop. And then if the stocker ratio of a given state is above the national average, it represents a net import of cattle. Okay. So understand this concept and understand that cattle tend to migrate from the coasts into the plains because that's where their stocker operations are. That's where your feedlots are. Okay. Um, Okay. The other thing from this that I want you to know is really the distinction between high plains feedlots, large commercial feed yards, okay, and Midwest farmer feeders, okay. know the competitive advantage of these two regions. Okay. And then if I asked you, okay, which region's going to have more head per per operation, right? Be the commercial feed lots in the high plains. Which one will be characterized by uh, uh, farmer feeders, where they're growing crops and then they're upgrading the value of their crops by feeding it to cattle and sell them as fed beef, right? That'd be Midwest feeding region. But those are the two regions that I care for you guys to understand. These are the two main finishing regions in the U.S. High Plains and the Midwest. So if I multiple choice question, which region of the U.S. is characterized by large commercial feedlots, right? High Plains. Which region of the U.S. is characterized by farmer feeders? Midwest. What's the competitive advantage for the farmer feeder in the Midwest relative to the High Plains? Well, they have low feed cost. Okay. Disadvantage, climate. They get a lot of rain, which is good for them to grow their crops, right? But it's a disadvantage in terms of uh, pen conditions, things like that. Okay. Then from this lecture, understand the things that impact forage system, right? So climate related things, temperature and precipitation. Okay. And then be able to explain why we're seeing such a reduction in our cow-calf herd in the US and why feeder prices have become so high because of that supply demand uh, related to cow inventory and cow inventory decreasing because of drought. Any other questions?
Thank you.
Does that make sense?
Yes, it does.
Yeah.
So we don't have to like worry about any of the region maps or anything, just like
No. Just very general. I just have these in here to make a point, right? To support the main claims I want you guys to understand is most cattle on feed are in the Midwest, farmer feeders, and in the high plains. You have some pockets here along the Snake River Valley, but it's much smaller compared to these two main regions. It's about 60 to 70% of fed cattle in the US are here, Texas, Colorado, Kansas, and then like uh, this area in Nebraska, and then in the Midwest. So the vast majority of cattle fed in the US are in just two real kind of ecotypes um, within the US. And those, you can group them together by region, but also production practices.
Is the Bill Mines paper that is from the first lecture open for being on the test?
Um, I guess the main thing that you should know about that is, what is the benefit of a stalker operation, right? It allows you to increase weight, increase uniformity, upgrade cattle. Um, yeah, that's the main thing. And what else? Um, then know the economic. Well, no, that's not in this lecture, is it? Let me see. Go back here to modules. Yeah, never mind. That's not. I was thinking about this lecture 6, but that's not in this exam. Okay, guys, any other questions?
Is there going to be any form of math on the second part of the exam? Because I know we have like the first one is all math, but I know like in our lecture we had some math, like simple math, like purchase price per head and stuff like that. Is there going to be any of that on the exam on Tuesday, or all of that's going to be on Monday?
So for the undergrads, all of that will be given on Monday.
So, so if you could just review um or just repeat what will be on Tuesday's exam, like from top to bottom, like this will be the question, and this is how you expect us to answer them, something like that, like the structure of the exam. If you could
Okay.
just repeat, that would be really nice.
Yeah. So,
The grad students.
okay. Let me. So for this, I'm just going to open the exam. So I'm going to stop sharing. Okay.
And will this recording be available later?
This recording?
Yes, sir.
Yes.
Because this has some questions that we can review it.
Yep. I'll upload it. Okay. So there's going to be some information based off review, right? Type of things around nutrition, which we covered in the first lab. Okay. There's going to be questions from uh, about the region specific, could be around uh, which region is characterized by what class of production practices, right? Like the farmer feeder versus the uh, high plains commercial feed yards, right? There could be questions about those two regions' competitive advantage, right? So the uh, high plains has a competitive advantage around climate, right? Drier, so better pen conditions, but also because it doesn't have much humidity, the cattle experience a lot of night cooling, which can help alleviate heat stress. Um, uh, Okay, there could be questions around risk category that we went over those three: high risk exposed, high risk non-exposed, low risk. But as far as format, there are 10 multiple choice. Those are 2 points each. Then there are 12 short answer, and that's a total of 42 points. And then the math section, there's 88 points total available for the math section. Um, Undergrads aren't going to be given that on Tuesday. They'll be given that in their lab. But graduate students, you will have to do all these math questions in uh, on Tuesday. So vast majority of this exam is those going to be based off very similar to those practice problems I uploaded on Canvas. So that's 88% or 88 out of 150. So over 50% of the exam total grade will be based off those math problems. So make sure that you run through those example problems I uploaded from last year's exam. Does that answer your question?
Yes, sir. Thank you so much.
You bet. So if I was you guys, I would use those study guides that I uploaded. I would study those. And then for sure, I would run through those practice problems I uploaded a couple of times, just making sure that you know how to implement the numbers given into those equations I provide. And then kind of truly high level type of information.
Can you go over the different transaction types, like the negotiated grid, forward contract, formula, negotiated purchases?
Yep. Okay. Let me share my screen again. Okay. Okay. So the USDA AMS has mandatory price reporting. Okay. So packing plants have to disclose the price that they're giving producers when they sell their fed cattle. Okay. They put these into four different buckets: negotiated purchases, negotiated grid, forward contract, and formula. Okay. Most cattle in the US are sold on using the formula transaction type. Okay. Negotiated purchases would be considered a spot market sale. So the feeder and packer agree on a price at the time of the deal. Okay. So you have a cattle buyer from Tyson come out to your feedlot. They say, yeah, we'll take your cattle. We'll give you $207 per hundredweight. You say, I want 209. You guys agree on 208, right? So you're negotiating that price at the time of the deal. Okay. Okay. Negotiated grid is that same kind of deal, right? But you're also going to receive a premium or discount based off how they do on the grid. So you will negotiate the base price up front at the time of the deal. But then the final settlement won't happen until after cattle are slaughtered. And so you could negotiate those premiums and discounts that you get from the grid, or they could be based off of USDA reported grids. Okay. Does that make sense? You understand those two?
Yes.
Okay. Forward contract. This is where a producer and the packer agree on a price for a future delivery date. Okay. So I could have a contract with Five Rivers, right, or JBS, and say, I'm going to have this group of cattle. We have 200 head in this pen that we're receiving. I will deliver 200 head of cattle to you in May, right? So 6 months out. And uh, uh, you will agree upon a price at that time. Okay. That could be based off of futures contracts, um, uh, what fed cattle are trading in the futures market at that time. It could be based off of uh, what the packer is you know paying people for their formula cattle at that time. But for the producer, it is a way to uh, uh, have some market risk protection, right? And kind of the same for the packer. Okay. Uh, Not very many people are marketing cattle on a forward contract. It does happen. Now the formula is what most people are selling this out. Okay. Um, so the sell price is determined by a formula that's tied to an external reference. So that could be the USDA 5-area weighted average. Okay. That could be the negotiated purchases that the packer is giving out around that time. Okay. So it could be based off of what they're paying people for the cash market. Okay. And then it's going to be combined with a grid where you receive a premium or discount based off of how they grade at harvest. So most people are doing a formula contract. Does that make sense?
Yes. So
Okay.
would we need
There's
to know?
not, there's not, there is no real, I don't want to say that. I would say at most, what I would do is kind of like a matching where I list the four contract types, and I have a definition out there, and you draw a line matching them to the definition. So it's not going to be like describe the formula price structure or transaction type. Does that make sense?
Yes, thank you.
You bet. Any other questions? I think we're at the time. Okay. You guys are welcome to reach out to me anytime that you like. Just let me know if you have any questions.